Hello, Dr. Friedman. Hello, Daniel Michaels. I have a problem that I need your consultation, Daniels. I've been testing here this engine so we can get a product out to the market, a UPS that will store the energy and then will be useful. We attempt to take it up to 80,000 RPM, and to calculate the efficiency of the UPS, I started with the movies that I sent to Dr. Friedman, and I started to calculate what I want to store in the engine. And of course I used this formula that it's been known in the internet, in Wikipedia, or in any physics book, of E-kinetic in watt-second, the weight M in kilogram, the radius in meter, and the speed in RPM. That'll give us in watt-second the storage of the flywheel that wheels in vacuum on magnetic bearings. So my calculation, you can see it in here. You can stop the movie and see all of it in your time. In here we have the storage in watt-second in 7,300 RPM, and then in the same weight and the radius, I change here the RPM, and that's the storage in 80,000. And of course I will calculate by here in the lab the descent by the resistance that I'm going to put in the transformer. Here, what I intend to do now to get it out to the market, it's 25 kilos. The radius is 10 centimeter, D 20, 80,000 RPM. That'll give us 1 giga and 250 megawatt second in storage. Now, our problem is that to reach this RPM, the current is a half amp, the voltage is 77.53 volt, and 60 second, 60 minute. That means to get it up to 80,000 RPM in 1 hour. That's what all technicians tells me, that they can get it up to 80,000 less than an hour. But here the number will be about 2,500 less than what we stored. So please go over all my calculation and give me a report if I'm wrong, if I got it wrong, or if I'm right. If I'm right, please come Monday at 11 o'clock to Merkaz Topaz Leonardo Hotel in Ashdod. We're going to discuss it with all the best enterprise and engineers of Israel. We're going to discuss it and we'll decide if we'll get the system out. Now, for checking out my patent and my progress of my hobby, I started it in a thermodynamic cycle to extract electric energy. Now it's actually extracting energy from vacuum. The original patent that I signed with Itzik Katz, from what I know, it's hidden there in the written. This patent, it's written there, but I don't know if all of it are mentioned and protected there. So we'll have to submit a new provisional. Now for the provisional, I'll go over the system. We have here the engine in vacuum, a magnetic bearing. Here we have a pressure bearing, and the other side to keep the center. The power here is very little. We can manage it with the tip of our fingers, and we're going to solve it magnetic, so we won't have we're going to have a field, a magnetic field all around the axe. Now, here I have a valve. Here in the lab I put it pneumatic, but actually it comes electric from the company that supplies the valve for 600 bar. Here I have a reactor. It's actually a pipe, 6 millimeters in diameter, 4 inside, and it's about 18 meters that are inside, rounded, and heated by the battery directly. Now I have here a pump, a water pump, and a bucket of water. The pump pumps the water in a pressure of 1,250 bar, so you can overcome the pressure that are built in the reactor that are up to 600 bar. Now, the engine are started with electronics and get it up to 12,000 RPM. In 12,000 RPM, in the piston that are shown in the patent, are being created a vacuum. The vacuum in light, the steam that comes inside, and because of that water vaporized in vacuum in 20 degrees, and the shock that coming inside the vacuum of the steam lights up, and we have here a reaction of plasma. The speed increases in 1 second 50, 80 to 100,000 in 1 second. A reaction are amazing. So in the system I put a system that can give drops of water from up to 100 of a cc to control the water, so I can control the reaction to get it to a point not above 100,000. Now, and then use the energy up to the descent of 25,000 RPM, and then give again a pulse of steam to get it up back to 80. That's the whole idea. Now, between pulse and pulse, for my calculation, it's actually the weight that I'm going to put in the flywheel. So, if I'm going to put 25 kilo, I will give a pulse of steam every day or so, 2 days. So it depends what we all, the team of engineers, are going to decide when we finish the probability here. We'll decide, but that's going to happen soon. And we should prepare all the documents and file it before it gets out. So, thank you. I'll be in touch. I'll write it down, all the schematic, and I will send it up to you. Thank you, Daniel. Thank you, Doctor. Bye-bye.